going to talk about a review of the unit circle. Now, in front of you, you see a copy of the unit circle, one that you probably reproduced in your pre-calculus class. A few things I want to remind you of. First of all, we are dealing specifically in radians. So yes, there are degree measures on here, but we will not be talking about them. Notice that the red lines, for example, each have denominators of 6. That's going to come into play later. Also notice that the coordinates of all the red lines are the same. The only difference is the positive and negative. Same holds true with the green lines. All the ones on the green lines have denominators of 4, and they are all the same coordinates, just with different positives and negatives. Pi over 3, the blue lines, same thing. They're all denominators of 3. They all have the same coordinates in the same order. Now, it is not always in your best interest to reproduce the entire unit circle anytime you need, say, the sine of pi over 6 or the cosine of pi over 3. So what I want to show you is a quick and easy way to generate the unit circle values that you may need whenever you're quickly evaluating these points in a problem. So, title this Unit Circle Review. And here's how this works. I want you to go down about 3 lines and write sine of theta. After that, I want you to draw a giant square root sign and put it over a denominator of 2. Skip a line, then write cosine of theta. Do the same thing with cosine. Big fraction bar, big radical, big fraction bar, and then the 2. Now, above the first radical, we are going to write the angles in quadrant 1 in radians. So we will start with 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, all you have to remember at this point, if you can generate this, you're halfway there. We have to decide which ones get bigger as you move up the unit circle. Is it the sines or the cosines? Now I'm going to write a y under here to remind myself that the y coordinate is the sine and the x coordinate is the cosine. As you move up the unit circle, the y coordinates get bigger. So this one is the one that starts with 0. So you put a 0 here, 1, 2, 3, and 4. On the cosine, you go in reverse order. 4, 3, 2, 1, 0. Now, in this diagram, you have any sine or cosine that you need for quadrant 1. For example, I want to know the sine of pi over 4. So, I go up here to pi over 4, and notice that the number right underneath it is a 2. So that tells me the numerator of pi over 4 is going to be the square root of 2 over 2. So the answer is the square root of 2 over 2. What about the cosine of pi over 2? Now I need to go to the cosine. Pi over 2 is the farthest one to the right. So that tells me it's the square root of 0 over 2, which is just 0. Let's try another one. The sine of pi over 6. Pi over 6 is here. This is the sine radical. It's got a 1 in it. So that tells me it's going to be the square root of 1 over 2, which reduces to a half. Okay. Now let's talk about tangent and cotangent. Now remember that tangent, for example, is y over x. So I'm going to write y over x right there. That's why I put the sign on top, is because I'm going to take, For the tangent of pi over 3, I'm going to take the sine of pi over 3 and then the cosine of pi over 3 and put them in that order. So this will be, at pi over 3, it's the square root of 3 over 2 over the square root of 1 over 2, or 1/2. Now, to clean this up, I need to take the 1/2 and I need to flip it up. It becomes 2 over 1. The 2's cancel, and I'm left with the square root of 3 over 1, which is the square root of 3. And there's the answer. Let's take the cotangent of 0. Now cotangent is x over y. So this time I need to put the cosine on top and the sine on the bottom at 0. So the cosine is the square root of 4 over 2 over the sine, which is the square root of 0 over 2. Square root of 4 over 2, that's 2 over 2, which is 1. The square root of 0 is 0 over 2, which is 0. So since I'm down to 1 over 0, this is undefined. So these are the way to get the unit circle values in quadrant 1. Now, there are two others we have not talked about yet. They are secant and cosecant. So let's review that secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine of theta. If you haven't watched the magic hexagon video, this will help you with remembering these as well. So let's take the secant of pi over 3. So it's going to be 1 over the cosine. So I'm going to put 1 over the cosine of pi over 3. Pi over 3 is here. Go down. That's going to be the square root of 1 over 2, which is 1/2. Take the 1/2, flip it up. 2 over 1. 1 times 2 over 1 is just 2. Let's take the cosecant of pi over 4. Cosecant is 1 over sine. So we're going to put 1 over the sine of pi over 4. Here's sine. Here's pi over 4. It's going to be the square root of 2 over 2. Flip that up. So it's going to be 2 over the square root of 2. So 1 times this radical, I'm going to have to move down here, is 2 over the square root of 2. I need to rationalize this, however. Square root of 2 over square root of 2. So that's 2 square roots of 2 over 2. The 2's cross out, and I'm down to the square root of 2. Okay, so we've had a big discussion about quadrant 1. What do you do if you're outside quadrant 1? It's very simple. Going back to what I said about the unit circle, if the denominator matches, you just use the same angle up here. You just have to think about if it's positive or negative. So, outside quadrant 1, you do the following. I'm going to have to be sliding back and forth, so bear with me. I want to do the cosine of 5 pi over 6. Now, 5 pi over 6, you must think about where that is. You're going to have to know that 5 pi over 6 is in quadrant 2. Okay, so we're in quadrant 2. Since the denominator is a 6, I need to go to the cosine line, and I need to look at pi over 6. So I know that the fraction is going to be the square root of 3 over 2, because it has the same denominator, square root of 3 over 2. Now the only thing I need to think about now is whether or not it is positive or negative. If I'm in quadrant 2 and cosine is x positive or negative? And in quadrant 2, x's are negative. So this answer is the negative square root of 3 over 2. Okay? Let's try another one. Sine of 7 pi over 4. Okay? Where is 7 pi over 4? You must know where these are. That's the only thing you need to know from the unit circle is what quadrant these angles are in. 7 pi over 4 is down here, quadrant 4. Okay? So, we'll come back to that in a minute. Quadrant 4. So, since the denominator is a 4 and we're looking at sine, you come back up to the picture, go to the sine line, go to pi over 4. Notice that it's a 2 under the radical. So that tells me it's going to be the square root of 2 over 2. Okay? Now, since we're in quadrant 4, we need to look at, is this answer going to be positive or negative? Now, sine is y. In quadrant 4, are y's negative? Yes, they are. So this answer does need to be negative. And there you have it. So, we have now done a quick review of the unit circle. If you can reproduce this right here, putting sine first, then cosine, labeling the quadrant 1 angles,